back, students. So let's see how to solve a problem on PDA. Obtain a PDA to accept the language L equals A raised to n, B raised to n for all n greater than or equal to 1 by a final state. So the question says we will have to accept this by a final state. What does it mean? It is n number of A's followed by n number of B's. So for this what we do is we read all the A's, push them onto the stack. So what we do is let Q0 be the start state and Z0 be the initial symbol on stack. So we will initialize the problem. So for doing the design, what we do is initially we will be in the state Q0. Then we will read all the A's, push them onto the stack. The moment we encounter the first B, we change the state and pop one A. For every B we read, we pop a A. Finally, after we pop all the A's, number of A's will be equal to number of B's. So there will be no more A's left to read. At that time, we will be having epsilon input, but the top of the stack will be Z0. When that state is encountered, we change the state again and make it as the final state. So for doing this, let's see how to write the transitions. Here I have considered an input A, B, B, B. 3 A's followed by 3 B's. To start with, I am in state Q0. So this is the initial configuration which I have considered. This is my stack. I have pushed Z0 onto the stack. So top of the stack is having Z0 and this is the input to be processed. Q0 is the start state. For this I have to write the first transition. So what I do is delta of Q0 A Z0. That is, when I am in state Q0, on reading the input A, when the top of the stack is Z0. So what should I do? I remain in state Q0 and I should push A onto the stack. So I write the RHS of this transition, that is Q0 comma AZ0. I repeat, when I am in state Q0, on reading the input symbol A, when the top of the stack is Z0, I remain in state Q0, I push A onto the stack. So it was like this. Now after reading this, the input A is already read. So the first input is read. Q0 has come here. A is pushed onto the stack. Now this is the current configuration. For this I will have to write the transition. I am in state Q0. The input is A. Top of the stack is A. So for this what I should do is, when I am in state Q0, after reading the input A, when the top of the stack is A, I push that A onto the stack and remain in Q0. So this is Q0 itself. The next A which I have read, I have pushed it onto the stack. So after this transition, my stack will look like this. Z0, A. So when we are writing the transition here, we will be writing the top two symbols of the stack. So this is how I have written A. Now I have read this A. So this transition will be repeated as many number of times as I want. Now the next transition, see, I am in state Q0. I am pointing to this A. So Q0 on A, top of the stack is A. So what happens when I am in state Q0, on reading the input A, when the top of the stack is A. So the same transition will give me this stack content. So this would be the stack content. Now what is the next transition. So what happens is, now I have read all the A's. I am still in state Q naught. I see the first B in the input. Now what is the design I am doing? I read all the A's, remain in the same state, push all of them to the stack. When I see the first B, I should change the state and then I should pop the stack content. So for that I have to write the transition. So I see the first B now, Q naught. I am still in state Q naught. I am in state Q naught. I see the B, top of the stack is A. So Q naught comma B comma A, this is equal to, I change the state to Q1 and I pop the top of the stack. So it is Q1 comma epsilon. Now I am in state Q1. So this is how my input looks like. I am in state Q1. I am reading the input B. Top of the stack is A. So for that what I do is, I am in state Q1. The input is B. Top of the stack is A. So delta of Q1 comma B comma A, this is equal to Q1 comma epsilon, because for every B I read, I pop A from the stack. So now this is the content. That is, I have read this B, I am reading the last B. I am still in state Q1, I see the B, there is still a A. So delta of Q1 comma B comma A, which is equal to Q1 comma epsilon. The same transition is used for this also. So now I am almost at the end. So the next is, all the inputs are read. I come to the end of the string. So what is the input here? Now the input is epsilon. All my input is already been processed. What about the content of the stack? There is only Z0 in the stack. All the A's have been popped up. So now for this state, I will have to write the transition. That is delta of Q1 comma input is epsilon. Top of the stack is Z0. So delta of Q1 comma epsilon comma Z0 is equal to, there is a change of state. So I change to Q2. Q2 comma I remain in Z0, mean I keep Z0 on the stack, because that has to be, this language has to be accepted by the final state. So if the language has to be accepted by the final state, I stop at this. If the same question says the language has to be accepted by empty stack, then the Z0 also has to be popped up. So other transition would be delta of Q1 comma epsilon comma Z0 equal to Q2 comma epsilon. This Z0 also can be popped. So you can write Q1 comma epsilon would be Q2 comma epsilon, which is accepted by the empty stack. So after writing the transitions, we will have to conclude the problem. For that, we will have to show this 7-tuple neatly again. The PDA to accept the given language L equals A raised to n, B raised to n for all n greater than or equal to 1 is M equals Q sigma tau delta Q naught Z naught A, where what is Q? Q is Q naught comma Q1 comma Q2. Sigma equals A comma B. Sigma is the input alphabets. Tau is stack alphabets, whatever gets into the stack. So what did we push? Z0 was already there, we pushed it first and then we pushed only A's. B's we didn't push. That is the reason tau equal to A comma Z0. And Q0 is the start state. Q0 which belongs to Q is the start state and Z0 belongs to tau is the initial symbol on stack. A we can also call it as F. A or F which is equal to Q2 is the final state. So the transition function delta. Whatever transition we derived so far, we are going to write here. That is Q0 comma A comma Z0 equal to Q0 A Z0 delta of Q0 comma A equal to Q0 comma AA delta of Q0 comma B comma A equal to Q1 comma epsilon delta of q1 comma b comma a equal to q1 comma epsilon q1 comma epsilon comma z naught equal to q2 comma z naught because the question says accepted by final state. Now how do we do the transition diagram? So take the start state which is q0, then state q1, q2 is the final state. So we see the transition. The first transition is A comma Z naught. There is transition from Q naught to Q naught. A comma Z naught is AZ naught. So A comma Z naught is AZ naught. There is one more transition Q naught to Q naught. A comma A is AA. So A comma A is AA. This is Q naught to Q1. So there is a transition on B comma A slash epsilon. So Q naught to Q1, this is B comma A epsilon. And Q1 to Q1, so this is again a self loop. B comma A is epsilon. So this is B comma A is epsilon. Q1 to Q2. So Q1 to Q2 epsilon comma Z naught is Z naught. So this is the transition diagram. So after doing this, we will have to see how to accept a string. For this, we will have to make the moves. For making the moves, I have taken a small string AABB. Initially, I am in state Q0. So, delta of Q0 comma AABB Z0. This is the top of the stack. So here what happens, this is the top of the stack here, this is the top of the stack, this is the input. When we are in state Q0, on reading the input A, when the top of the stack is Z0. So Q0 comma A comma Z0. For this you have to go and see the transition. Q0 comma A comma Z0. What happens? You will push this A onto the stack. So this will be Q0 AZ0. So here Q0 comma A comma Z0 will be Q0. This A is gone. What is remaining is ABB. So Q0 ABB. This A comes and sits on the top of the stack. So this A comes here. This first A, it comes here. What is remaining is ABB. This will become AZ0. This is the top of the stack. Now we are here. This is the current configuration. Q0 comma A comma A. So go back and see the transition diagram. Delta of Q0 comma A comma A. We remain in state Q0 and push this A onto the stack. So I read this A, Q0 comma, this A is right and I have to push it onto the stack. So what is remaining is BB. This A comes and sits here. So it will become AA Z0. Now Q0 comma B comma A. Go back and see the transition. Delta of Q0 comma B comma A. There is a change of state to Q1 and we are popping the content of the stack. So Q0 comma B comma A, change the state to Q1 and this B is right, remaining is only B and this A is popped. So remaining is AZ naught. So Q1 comma B comma AZ naught. Now what we have to see is Q1 comma B comma A. Q1 comma this transition delta of Q1 comma B comma A, which is equal to Q1 comma epsilon. So we need to pop. So when we pop this, it becomes Q1 comma epsilon comma this is popped. This A is popped. This is Z naught. So Q1 comma epsilon comma Z naught. Go back and see the transition. Q1 comma epsilon comma Z naught, which is equal to Q2 Z naught. So this input epsilon remains to be epsilon. There is a change of state to Q2. Z naught is not popped. We keep Z naught as it is. The input is accepted. So this is how we make the moves in a PDA, and we have accepted the string. So we can also see how to reject a string. If the string is not of the form a raised to n, b raised to n, that is equal number of a's followed by equal number of b's, then that has to be rejected. For that I have taken one more string, that is q naught comma triple a 2 b's comma z naught, that is q naught comma AAA BB comma Z naught. Make the move. So Q naught comma A comma Z naught. That is, you read this A, push it onto the stack. So you remain in state Q naught. First A is read. Remaining I have 2 A's, 2 B's. This A, first A will come and sit in the on the stack. So this is the arrow shows the top of the stack. Now Q naught comma A comma A. Again I have to remain in Q naught and I have to push that A onto the stack. So I am in state Q naught. This A is gone. What is remaining? ABB is remaining. This A comes here. So it is AA Z naught. Now Q naught AA, the same transition. This A will go and sit on the top of the stack. So remain in Q naught. What is remaining on the input side? BB. This A will come here. So 3 is Z naught. Now Q naught B A. So we will see the first B. When we see the first B, there is a change of state. So Q naught becomes Q1. This B is read. What is remaining? 1B is remaining. This A is popped. What is remaining? 2A Z naught is remaining. Now Q1 comma B comma A. So we will pop this B. After popping this B, we are still in Q1. This is pop. This is epsilon. Q1 comma A Z naught. This A is gone. So 1A is remaining. Q1 comma epsilon comma A. Now the input is exhausted. What is the input? It is epsilon. What is the top of the stack? It is small a. So what is the PDA we have done? When the input gets over, that is when the input is fully processed, stack should have only Z naught or stack can be empty. So now this is A is remaining in the stack. It means that this transition we have not defined. Q1 comma epsilon comma A. Q1 comma epsilon comma A, this transition we have not defined. So the PDA will not know what to do when it comes across this transition. The PDA will halt. So this transition is not defined. So since the transition is not defined, the string is rejected. Okay. So this is one input. By changing the final transition from Q naught comma epsilon comma Z naught to Q2 Z naught or to this, it can be accepted by the empty state. If you want, you can just take it as epsilon also. This also you can pop off. That will be Q naught comma epsilon will be equal to q2 comma epsilon. So that is the string is accepted by empty stack. For that, diagram would look like this. So that is about the language L equal to a raised to n, b raised to n for all n greater than or equal to 1 accepted by a final state. And one thing in PDA, don't take the value n equal to 0. If n equal to 0, there is no string at all. So we need not have to design a PDA for it. So we can just keep n greater than or equal to 1. If the string is 0, then you need to define for accepting a empty string. You need to define the transition for accepting the string. Thank you.